Now we discuss how price, demand, revenue, cost, and profit are tied together in typical applications. Although either price or demand can be used as an independent variable in a price-demand equation, it is common to use demand as the independent variable when marginal revenue, cost, and profit are also involved. So on this example, you will see the solution is a bit long. I will try to explain all these marginal functions. A company's market research department recommends the manufacture and marketing of a new heat phone. After suitable test marketing, the research department presented the following price-demand equation. Okay, so this price-demand equation is given as equation 1. In the price-demand equation, which is 1, the demand x is given as a function of a price p. By solving first one for p, okay, here how you can solve this explained, but in the exam, so in general we don't give this explanation. We obtain equation 2. This is important. Here p is considered as an independent variable, x is considered as a dependent variable. In this form, x is considered as an independent variable, p is considered as a dependent variable. In general, both of are dependent and independent variable actually, okay? So price or demand can be used as an independent variable, okay? Where x is the number of his phone that retailers are likely to buy at $P per set. For financial department provides the cost function. Okay? By using the regression analysis, this function is given. Where $7,000 is the estimated of fixed cost, as you know, and $2 is the estimated of variable cost per heat phone. X is the number of the heat phone, so this is the item cost. So according to this fact, just we have two facts: price demand equation and the cost function. So by using these two facts, we can write the revenue function, we can write the profit function, and we can discuss the marginal of these three functions. So let's look at the first question. Find the domain of the function defined by the price demand equation from here. So what we know about this one, I will show that the solution of your textbook I will share. But basically what we need here, x is independent variable. Independent variable. So x, let's say x is the independent variable. So we should find the domain for x. So x demand represents the demand, number of the phone numbers. So x cannot be negative. So first we know x is bigger than 0. Maybe it can be equal 0, there is no problem. Secondly, we know price have to be bigger than 0. Otherwise, nobody willing to sell some item, some product, okay? So P bigger than 0. So P bigger than 0 implies 10 minus 0.001x bigger than 0. So by solving this equation, we will find the upper bound for the x. In the next page, you can see the solution of the part A. Since price P and demand x must be non-negative, so both of them are positive, okay? We have x bigger than 0 and P bigger than 0. So we add the 0.001x both sides, so we obtain this inequality. And by dividing the both sides 0.001, we obtain x is less than 10,000. So as a result, x should have to be between 0 and the 10,000. Let's look at the second question. Step by step, let's look at the questions. So find the find and interpret the marginal cost function C prime. So C prime is actually given marginal cost function. To say a marginal cost function is enough, you should know marginal cost function is the derivative of the cost function. So what is C prime? From here you can differentiate. Derivative of the 7,000 is 0. Derivative of the 2x is 2. So a marginal cost function is directly, you can say that, which is 2. Okay, so we found. So let's interpret this result. We can consider this in the question. It said $2 is the estimate of the variable cost per heat phone. So this is change of the cost when the number of the heat phone increase 1 unit. Okay, so for the each increase of the each unit for the increase of the heat phone each unit, the cost increased $2. Okay, and on the other hand we have another interpretation about the next item. So 6 is from the x to the x plus 1 item. So the price of the x plus first item is C prime of x. So this is fixed, which is 2. So always x plus first item is $2. So first item price is cost is $2. Second item cost is $2. Third item cost is $2. For the any item, it is cost is $2. So the marginal cost function is 2. Since this is a constant, it costs an additional $2 to produce one more heat phone at any production level. Or for an item, the cost is $2. Let's do part C. Find the revenue function as a function of x and find its domain. Maybe we can say something here. Also, we know that C prime x approximately equals C of x plus 1 minus C of x. Okay, in the previous record, in the 2.7.1 record, I explained. So since this is constant here, it will be exactly equals in that question. Okay, because it is linear. Okay, our cost function is linear. Otherwise, approximately they are the same or similar. Find the let's look to part C. Find the revenue function as a function of the x and find its domain. This is not difficult in my opinion for you. Revenue function equals demand times price. So we know the price with respect to x. So easily you can calculate the revenue. So what is the domain? Let's write first of all. So this is revenue function. The domain is the same with the price demand equation. Let's look to solution of the part C from your textbook. As you see, everything is the same. The revenue is number of heat phones sold, price per heat phone. So x times p. By using the equations, we can write the revenue function in the following form, and the domain are the same because you obtain by using the price demand equation. Let's do part D. Find the marginal revenue at the given level. So marginal revenue is, and interpret these results. The marginal revenue is R prime. So we should calculate derivative of the R. Maybe from here, it is not easy to calculate for you. Here I made a mistake. X. Okay, let's close the parentheses. So by using that formula, 10x minus 0.01x squared, easily you can obtain. So 10x minus 0.001 x squared, you can calculate revenue. Derivative of 10x is 10. Derivative of minus 0.x squared is 2 times 0.001 x. So 0.002x. Okay. So you should calculate the R prime of 2000, R prime of 5000 and 7000. Okay. After calculating these values, just you find the marginal revenue at that level. Interpret this result. So what is that one? The change of the revenue at the when the demand is 2000 is blah blah blah. Okay, so we should say the such sentences. Let's look at your textbook solutions. The marginal revenue is that one, as we calculated. So at that point 2000, actually just here, for example, for the 2000, this is 10 minus 0, 2 times 2000. So this is 4, and as a result that is 6. Okay, so this means this is 6, this is positive. Okay, there is no problem. So change in revenue per unit change in production are $6. Okay, so this is our interpretation. Since 6 is positive, so revenue increase at the production level x equals 2000. Here revenue is 0, so there is no change. Okay, so at the 5000 output level, revenue does not change. Okay, when x change small. Okay, when a small change in production, or change in the revenue per unit change in the production is $0. You can say this, similar sentences from here. Okay, $0. So respectively, in the one sentences, it is explained in the your textbook instead of repetition. So for the 7000, that is an important point here. Let's look. This is negative. Okay, this is important. So revenue decrease. That means revenue is decreased. So at the 7000 output level, revenue decreases with an increase in production. Or when production changes 1 unit, revenue decrease $4. Okay, maybe we can say that fact in different way. When production changes 1 unit, okay, revenue decreases $4 at the 7000 output level, or revenue decrease $4 per unit change in production. Okay, this is also correct at the level 7000 output level. Okay, let's look to the next question. Party, graph the cost function and revenue function in the same coordinate system. Find the intersection point of these two graphs and interpret the result. Actually, I will focus on the interpretation of these results, because easily you can sketch that graph on the same coordinate system. But when finding the intersection point, maybe you need some calculation, because revenue function is linear function, as you can sketch. Okay, example I will show that we have a linear function. When x equals 0, this is 7000. So the graph like this one. Okay, and the revenue function is quadratic function. I don't know where they intersect, but I'm checking your textbook. Okay. The revenue function, this is revenue function. So when x equals 0, this is 0. So graph like that one. Okay, this is the revenue function graph. So on these two graphs, we discussed some things. Actually, we should find the intersection points. I will show that the solution to you. So let's look to part E. To find the intersection point. Actually, what is this point? When the revenue and the cost intersect at the some point, this point is the break-even point. Okay, it is called the break-even point. The intersection point of the revenue and the cost are called the break-even point, because revenue equals cost at this production level. So the company neither makes losses money, but just break even. Neither makes profit nor losses money. It is not correct. Okay, let's write here. The company neither makes profit nor loss money, but just break even. Okay, so cost and revenue is the same. There is no profit, there is no loss. Then break-even point are obtained as follows. Okay, please be careful. Now we have new definition, break-even point. Okay, up to today we learned several definitions. Equilibrium point for the price demand and price supply equation, and we have learned another one, but I could not remember now. So here we learn break-even points. Okay, so by solving this equation, revenue equals cost equation, we can find. So you should be able to solve the quadratic function. Okay, so from here you obtain this quadratic function, and we will use the discriminant formula. Okay, I will write the discriminant formula here. For the quadratic function ax squared plus bx plus c equals 0, we have the following formula to find the solution of this equation. So we define delta, which is b squared minus 4 times a times c. If delta is positive, okay, so we have two solutions, x1 and x2 equals minus b plus minus square root of delta over 2a. So by using that formula, you can find the root of any quadratic function, but if delta bigger than 0. It can be equal 0, but if the delta equals 0, there is only one solution. If delta less than 0, there is no solution. So here, by calculating by using delta formula, this solution can found. Maybe you can find by different way. Here it is not easy to see this one because your quadratic function is this value, plus 7 millions equals 0. But if you can find in the exam, you can use this idea. You should find the 2 factor of the constant term, and the summation of this 2 factor, if that is 1, okay, summation of this 2 factor give us the b. You find this value, but here b is negative, this is negative, so all factors should be negative in this case. So what is this factor? Minus 1000, there are 30, minus 7000. So product of these two value are 7 millions. So summation of this two one is minus 8000. Okay, so that is xx. So we can say that from here x minus, and try to find the green one, x minus 1000 times x minus 7000 equals 0. So x equals 1000 and x equals 7000 are our solution. But in general, you can use the discriminant formula. There is no problem. So at this level, at the break-even point, you can calculate the revenue cost, okay, and you will see, of course, at the each point, the revenue and the cost is the same. Okay, this is verification of that result. So the break-even points are this point: x is 1000, y is 9000, x is the 7000, and y is 21,000, as shown in the figure. I will show that the figure to you. Okay, So further examination of the figure shows that the cost is the greater than the revenue for production level between 0 and 1000 and also between 7000 10,000. On this graph I will show that. Consequently, the company incurs a loss at this level. But contrast, by production level between 1000 and 7000, revenue is greater than the cost and the company makes profit. Okay, let's look to that graph here. Blue one is the revenue function. This is the revenue function. Okay, blue one. Red one is the cost function, as I showed here. So here in the between the break-even points, revenue is bigger than the cost. Okay, for example, I don't like that situation. Okay. Why it happened, I don't know, but I don't like the situation. So anyway, for this point, for example, between 4,000 5,000, this is the cost function, cost value, and that is the revenue value. So revenue is bigger than that one. So here, revenue bigger than cost between the 1,000 and 7,000. Okay, so between 0 and 1,000, revenue cost is bigger than. Okay, so here you can observe cost is bigger than revenue. So here cost bigger than revenue, and here cost bigger than revenue. So when revenue bigger than cost, that means revenue minus cost is positive. When cost bigger than revenue, this means revenue minus cost less than 0. So what is revenue minus cost? This is profit function. Okay, so that is profit function. So on this interval, 1,000 and 7,000, we have a profit. On the interval 0 to 1,000 and 7,000 to 10,000, 10,000 is our domain. The company may lose money, make loss. Okay, this is here. Profit is negative. So let's look to next question. Part F. Find the profit function and its domain and sketch the graph of the function. So profit function. Actually, from here I can make some comment. Then I will show that the solution to you. This is 1,000. This is 7,000. The domain will be same 10,000. So as you see here, between 0 and 1, domain revenue is negative. So at the point 0, this is 0. So by increasing, it goes to 0. Maybe this is parabolic again. I don't know. Actually, I know this is parabolic because of the revenue function. So it increase. At the somewhere, I don't know where, it makes the maximum profit. Okay. So it makes the maximum profit and turns. And again, at the point 0, it is reached 0, 7,000, it is reached 0. And after the 7,000 production level, it makes loss again. So it goes negative. It is negative value. Here the exact graph of that one. So profit function. This is marginal profit. Here the profit function. Okay. And I will show that the profit function graph. So profit function is revenue minus cost. So this function is profit function. Okay. So this is profit function. So this is quadratic function. By using the idea how you can sketch quadratic function, maybe you can find the maximum value by different way. Actually, the root of the marginal profit function will be the maximum value of the profit function. Okay, in the future you will see. But here I can say that. So, here. For x equals 0, it starts from the minus 7,000. So our graph will start minus 7,000 here. And you can find the maximum value. And we know that these are the x-intercept of the profit function. Because at that point, there is no profit. Okay, profit is 0. So this is the profit function graph, which is quadratic function. At the some given level, according to question, this is the next part. Okay, you can calculate the profit or marginal profit. Actually, next part is related with the marginal profit, not the profit. Sorry. Okay. So the profit function graph like this one. Actually, I should carry this one in the previous page. So let's look the next one, part G. Find the marginal profit at this level. This record very long, I know that. Interpret these results. So the marginal profit is a derivative of the profit function. So from here, minus 0.002x plus 8 is our profit function. So marginal profit function. At this level, you can calculate. So that means when the production level is 1,000, the company profit increased by the rate $6. Okay. So at the production level 4,000, okay, the change in the profit is $0, while the change of the production is 1 unit, or a small change. Okay. According to this result, we can say that at the production level 6,000 items, okay, change in the profit per unit change in the production is minus $4, or change in the profit decreased $4 per unit change in the production at the 6,000 level. Okay, these are the comments about this situation. These are the interpretation of that one. Okay, as I said at the beginning of this video, we have a long application question. So by this way, we complete the solution of this question. But this is very important question. This is summarized what I know up to today.